So in class 3 we have seen laws of photoelectric effect and also some graph. That is, if you plot a graph of frequency versus stopping potential or kinetic energy, the graph is something like this. See in this graph, this gives threshold frequency nu naught, and this is W naught by E, or W depending upon it is V naught or kinetic energy, and slope gives H or H by E. Slope is equals to H or H by E depending on Ke or V naught. We have discussed all this in the previous class. Now let us see some more graphs now. Let us see some more important graphs now. Now we know that H nu is equals to H nu naught plus half m v square, or H nu is equals to H nu naught plus EV naught, because half mv square is equals to EV naught. This is velocity. This is stopping potential. This is stopping potential. And this is work function. W naught. This is W naught. It is work function. And nu naught is the threshold frequency. Now in last we have discussed that the current is directly depend on the intensity but not on the frequency. Therefore, current intensity graph. Current intensity graph. So if plot a graph of this is, let us say this is intensity. If you take this as intensity and this is current, then what happens? As the intensity increases, number of photons increases, therefore collisions increases, number of electrons released increases, therefore current increases. Therefore, if you plot a graph of intensity versus current, the graph is a straight line proportionality graph. If you plot a frequency versus intensity, then what happens? If you plot a frequency versus intensity, then what is the shape of the graph? So the intensity increases, current increases, but not frequency. So let us take it has a frequency, then you will get a graph. Frequency here, let us take frequency here, and intensity here. No problem anyway. And intensity. If the frequency increases, what happens? The intensity does not change. Therefore, the plot will be something like this. The intensity does not depend on the frequency. The intensity depends only on the current depends on the intensity. Intensity increases, current increases, but frequency increases, then intensity, there is no change in the intensity. Therefore, frequency increases, then we can take it as current. Intensity or current. The frequency increases, current does not increases. Frequency increases, current does not increases. Current increases with intensity only. We can take both because intensity proportional to current. Okay. Next one is, if you take a plot of kinetic energy versus intensity. Kinetic energy versus intensity. Kinetic energy versus intensity. Then therefore again also, if intensity increases, what happens? Intensity increases means the current increases. Therefore the kinetic energy does not increases. Kinetic energy increases when you increase the frequency. Kinetic energy increases if you increase the frequency. Kinetic energy increases if you increase the frequency, but not intensity. These are some basic graphs. Intensity versus current. The current proportional to intensity. Therefore, straight line. Current or intensity versus frequency. Therefore, if the frequency increases, current does not changes. It is a constant. And intensity increases, kinetic energy does not change. These are some graphs. Again, most important graphs, and which are giving regularly in the examination. Let us discuss now. This is anode potential. This is anode potential. This is photocurrent. Photocurrent. This is minus V naught and potential V naught. V naught potential fixed as V. This is I1, I2, I3. Therefore here I3 greater than I2 greater than I1. Now here what is happening? We are taking a graph of anode potential versus photo current. Anode potential versus photo current. Here if you fix the frequency almost constant, we are taking the potential and intensity. Now here I3 intensity I3 is greater than I2 greater than I1. What can we infer from this graph is, see, if you increasing the intensity, what happens? So for I1 intensity current, let us say some 10 microamps. So if I2 intensity current again coming increases, photo current increases, let us say some 15 microamps. If you again increase the intensity, the photo current becomes 20 microamps. This is increasing like this. Therefore, if the intensity increases, the photo current is increasing, but the stopping potential, this is what is called as stopping potential. Stopping potential does not increases. If you increase the intensity, intensity increases implies current increases. And stopping potential is independent of intensity. Stopping potential is independent of intensity of incident radiation. Here frequency always remains constant. Frequency of incident radiation remains constant. Frequency of incident radiation is equals to this is most important graph. If you increase the intensity, then what is happening? Intensity increases means current increases. We have seen this. Intensity versus current. We have seen like this. So intensity increases, current increases like this. Intensity increases, current increases. But intensity increases means kinetic energy remains constant. Intensity increases means kinetic energy or stopping potential remains constant. We have seen the previous board. Therefore, here intensity increases, the current increases, but the stopping potential remains constant. This is very important graph. Let us see. Next one is the with frequency how it varies. Next one is with frequency. Let us say how it varies. Same anode potential, and if you change the frequency, here we are taking frequency constant. If you change the frequency, then what happens to the stopping potential? If you change the frequency, then what happens to the stopping potential? Let us see now. So this is anode potential. This is anode potential. Again, this is current. Now what happens? This is called as saturation current. That is maximum current. Saturation current or maximum current. Saturation current. This is minus VO1, minus VO2, minus VO3. This is for frequency nu1. This is for frequency nu2. This is for frequency nu3. Nu3 greater than nu2 greater than nu1. Here previous board we taken frequency as constant. Then we have taken only one potential we got. But same graph, current versus anode potential. Previous graph here current is what we call this, intensity is increased. Previous graph we have increased the what we call this, intensity. We have increased the intensity I1, I2, I3, and V0 remains constant. Now what we are doing? We are making the current as constant. Saturation current remains constant. And now what happens? We are varying the frequency. You are varying the frequency. Nu3 greater than nu2 greater than nu1. Now what you can infer from this? See, if you increase the frequency, what happens? Kinetic energy increases. Or if you increase the frequency, here V naught increases. If you increase the frequency, here V naught is increasing. If you increase the frequency, stopping potential is increasing because H naught remains constant. This is constant. Therefore, nu increases, kinetic energy or stopping potential increases. Therefore, let us see here. Here nu for nu1 for nu1 frequency stopping potential is minus V01. For nu2 frequency stopping potential is minus V02. For nu3 frequency stopping potential is minus of V03. Therefore, here as frequency increases, stopping potential is increasing, but not the current. This is the another graph where here intensity remains constant. Intensity is equals to constant. Intensity remains constant. Previous one, frequency remains constant. Anode potential versus current gives different intensity is varying. Therefore, current is varying, but not stopping potential. But here, what we have taken here, intensity remains constant. Stopping potential is increasing if we increase the frequency. This is the important graph. Frequency increases, stopping potential increases. Frequency increases, stopping potential V naught increases. This is the inference from this graph. Okay. Now let us see for solving problems. For solving problems, we know that 1 electron volt is equals to 1.602 into 10 power minus 19 joules. 1 electron volt is equals to 1.60 10 power minus 19 joules. We know that E is equals to H nu. That is equals to Hc by lambda joules. Hc by lambda joules. Now this implies energy E is equals to H is 6.602 into 10 power minus 34 joule second into velocity of light 3 10 power 8 meters per second by lambda. This is joules. Now to convert this joules into electron volts, we have to divide the energy in joules with the charge of electron. Therefore, energy E is equals to 6.602 into 10 power minus 34 into 3 into 10 power 8 by 1.602 into 10 power minus 19 into lambda electron volts. Lambda electron volts. Okay. Now if you take this value, we have converted because if we deal with the fundamental particles like electrons, protons, alpha particles, then we have to put the energy in electron volts. Then we measure the energy in electron volts. Minus 13.6 by n square z electron volts, energy of electron, just like that. Therefore, energy should be measured in electron volts if you go for the fundamental quantities. This comes out to be, if you do this one, 12.406 into 10 power minus 7 by lambda electron volts. Now if you take this one, 12,406 into 10 power minus 10 by lambda electron volts. This is the expression for energy. But see, generally, if you are given some lambda is equals to 6,200 angstroms. If you are given lambda is equals to 6,200 angstrom, then what is the energy of the photon? What is the energy of the photon? Then what we have to do? This we have to take 12,406 in general we take 12,400. For simplicity sake we take 12,400. If we take 12,406 also no problem. Then we take 12,400, no problem, no matter with the 6 into 10 power minus 10 by lambda 6,000 angstrom, 6,200 into 10 power minus 10 meters. Therefore, this becomes 6,200 into 10 power minus 10 electron. These two gets cancelled. 62 2. So that is equals to 2 electron volts of energy. Therefore, what I can suggest you is, therefore we can take generally we take. Therefore, the energy E is equals to 12,400 into 10 power minus 10 by lambda electron volts. Now, therefore, what we have done here, if lambda is given in angstroms, this is cancelling. Therefore, this should be, we can cancel this one and this should be in angstroms. So, for suppose, if you are given some lambda is equals to 31 angstroms, 3100 angstrom. You are given lambda is equals to 3100 angstroms. Then the formula becomes E is equals to 12,400 by lambda in electron volts. This you have to use. Now, if you use this one, remember carefully, if you use this one, lambda should be in angstroms. Lambda should be in angstroms. Then what happens? Lambda should be in angstroms means, then what happens here? Then what happens? This equals to 12,400 by, substitute lambda as only 3100 because 10 angstrom turn minus 10. This minus 10 and this one gets cancels here. Only this, then the equation becomes 12,400 by 3100. No need to put again angstroms here. Then what happens? 3100 cancels 31 4 times. That is equals to 4 electron. Moral it is 4 electron volts only. Therefore, so if you are given lambda in angstroms, then directly put that value and don't put again 10 power minus 10 there. For example, if you are given 310 nanometers, if you are given 310, E is equals to how much? When lambda is equals to 310 nanometers. Then you have to convert this into angstroms. This becomes 310 into 10 power minus 9 meters. No, nanometer 10 power minus 9. Then this becomes 3100 into 10 power minus 10 meters. I have added one 0 and removed 1 0. This becomes 3100 into power minus 10 meters equals to 3100 angstroms only. Therefore, then put 12,400 by 3100. Therefore, because this final result should be in angstroms. If you are given 612, we are given 0.62 micrometers. If you are given 0.62 micrometers, then how to convert this into angstroms? 0.62 into 10 power minus 6 meters. To convert this into angstrom, we should require 10 power minus 10. Therefore, put 10 power minus 4, divide with 10 power minus 4, no harm. Multiply with 10 power minus 4, divide with 10 power minus 4, no harm. This becomes 0.62 into 10 power minus 10 by 10 power minus 4 meters. This becomes 0.62 angstroms by 10 power minus 4. This becomes 0.62 into 10 power 4 angstrom. I have to send this upwards. This becomes 0.6200 angstrom. This becomes 6200 angstroms only. Therefore, any value that should be given here, that should convert in 10 power minus 10 because 10 power minus 10 is 1 angstrom. So this is something about the conversion. Then this is very important formula. One more thing is, if you are given energy, then calculate wavelength. Then what you will do? If you are given energy and asked to calculate the wavelength, then what will we do? If you are given energy and asked to calculate the wavelength, then lambda is equal to this equation. Lambda is equal to 12,400 by energy in electron volt, because we are getting energy in electron volts. Then from this equation, lambda is equal to 12,400 by energy E in electron volts. For example, if you are given 21.7 into 10 power minus 19 joules of energy. If you are given energy is equals to 21.7 into power minus 19 joules, then what the value you have to put here? You shouldn't put direct like this, but to convert this joules energy into electron volts. This becomes 21.7 into power minus 19 by 1.6 into power minus 19 electron volts. To convert the joules into electron volts, divide with the charge of electron. Therefore, these two gets cancelled. This is 13.6. This becomes 13.6. Then put the value 12,400 by energy. This is angstroms by 13.6 angstroms. If you are given 2 electron volts, energy E is equals to 2 electron volts. Then what is lambda? Lambda is equals to 12,400 by 2. If you are given energy in electron volts directly, then you put 2 as it is. If you get energy directly in electron volts, put 2 as it is. No problem. This becomes angstrom. This becomes 6,200 angstroms. If you are given energy in joules, then convert that into electron volts and then Put the value here. Another important thing here is so if what we call this energy, if electron is accelerating potential V is equals to 2 volts, then what is the wavelength? See, 2 volts of energy, 2 volts of potential is equals to 2 electron volts of energy only. 2 volts of potential always equals to 2 electron volts of energy. If you are given 2 volts here, then again what is the energy becomes? 2 electron volts only. Then what is the wavelength? So 12,400 by 2, 6,200 angstroms is the wavelength. If you are given 3 electron volts, then what is the voltage? Then voltage is nothing but 3 volts only. Therefore 3 electron volts of energy becomes a potential of 3 volts, and also 2 volts of energy becomes a energy of 2 electron. This is something about the conversions. So if you are given potential also, they take it as energy, the same value energy in electron volts. So if you want to convert 3 electron volts into joules, then what should be done? 3 electron volts, then how to convert joules here? 3 into 1.6 into 10 power minus 19 joules. We are dividing the joules with the charge of electron to convert joules into electron volts. Now if you are given electron volts, then how to convert into joules? Replace the value of E here as charge of electron. That should be converted into joules only. So this is the conversion factors. These are the conversion factors. Okay. Next one is, what is the power? What is the power? Power is equals to work by time. Work will be taken as energy by time. Therefore power P is equals to energy h nu by T. For n number of photon, I told you in the beginning only 1 electron for 1 photon. For n number of photons, total power is equals to Ne E is equals to h nu, nh nu by T. Again nu is equals to C by lambda. Therefore P is equals to nh nu is equal to C by lambda into T. Then wavelength lambda is equals to NHC by P. These are all very, very important conversion factor. NHC by T lambda, NHC by lambda T, or NHC by PT gives lambda. Therefore we can say generally power is equals to power is nothing but intensity is equals to, generally intensity is equals to energy per unit time per unit area, but energy by time is power. Therefore intensity is equals to power by area. Generally we take the shape of a sphere for all calculations. I is equal to r square. Therefore intensity proportional to 1 by r square. Intensity proportional to 1 by r square. This is something about the power here. And finally, and last one in this topic is, see, you are given Planck constant H is equals to 6.625 into 10 power minus 34 joule second. If you ask it to calculate Planck constant in electron volts, then H is equals to 6.625 into 10 power minus 34. Joule should be converted into electron volts, means divided with charge of electron. 1.10 power minus 19 electron volt second. 10 power minus 15, so almost 4 times. This implies H is equals to 4 into 10 power minus 15 electron volt second. Planck constant in terms of electron volt second is H is equals to 4.14 into 10 power minus 15 electron volts. Now, so rest mass energy of photon is always 0. Rest mass of photon is always equals to 0. and also effective mass is effective mass. We can calculate the effective mass. Effective mass of photon as E is equals to mc square. This implies m is equals to E by c square. Momentum of photon, momentum is equals to mass into velocity, that is equals to E by mc square into c. So it gets cancelled. This is equal to momentum mv is equals to E by mc. E by mc is the momentum of photon. This is also taken as h nu by c square. Nu is equals to c by lambda. Therefore, hc is equal to c plus c by lambda into c square gets cancelled. H by lambda c is the mass of photon. This is the momentum of photon. This will come to end of photoelectric effect.